So today we are going to, this video will cover the beginning part of chapter 2, section 2. We're going to learn about functions and function notation. So whenever you have a function, for each x value, there's always only going to be one y value. So if you're given a list of ordered pairs, your x's can't repeat. Okay, your y's could repeat. And then function notation, this f of x, it's really just a fancy way of saying y equals. So we're used to seeing our equations written like this, y equals x plus 1. What we're going to be introduced to now is the function notation. So instead of saying y equals, we're going to say f of x equals. Now, you may be asked to graph multiple equations on the same graph. So what they could do is, let's say they want you to graph two different lines on the same graph. They could introduce another letter, and they could call it g of x. And then they could ask you to graph that one as well. So it's just a way of maybe distinguishing between the different lines on your graph. So the next thing we're going to do is determine what becomes a function. So again, if you remember what I had just said, that whenever I give you a list of ordered pairs, in order for a relation or a set of ordered pairs to be a function, all of the x's in my ordered pair need to be different numbers. So if I look here at the 1, the -2, and the 3, because these are all different numbers, I will say that yes, this is a function. Now, if I go to look at number 2, soon as I see that one of the x values repeats, and notice this 1 is repeating 3 different times, my answer here is no, this is not a function. Now, the y's can repeat, but not the x's. The next thing here is a mapping diagram, and what I need to focus on here are the arrows that are coming out of the numbers. As long as each one of the x numbers in that x oval has only one arrow coming out of it and it maps with exactly one y, then I will say yes, this represents a function. But as soon as one of these numbers has 2 arrows coming out of it, this makes this not a function. Now, I could also turn these mapping diagrams into a list of ordered pairs. I could say that this first one is the ordered pair 1, 2. Then this one would become -2, 4. And then this would become 3, 1. So I could also turn my mapping diagram into a list of ordered pairs. Same thing here. I could list this as 4, 1. But then when I get to the 2, it's mapping to the 1. And it's also, the -2 is also mapping to the 0. So notice how the -2 repeats. This is why this is not a function. Another way that you can tell if something's a function when you're given a graph is called the vertical line test. So whenever you have a graph, if you can draw a vertical line down through the graph, and if it touches your graph more than once, then it's not a function. So for example, if I draw a couple coordinate planes here, every linear function, when you don't have an exponent on any of your x's or your y's, it's always going to be a function. So all straight lines are always a function. Now, I'm not trying to make this fail. I'm trying to find, or I'm not trying to make it work. I'm trying to make it fail. So if I were to draw a diagonal line here, and let's say this is the graph, then what I need to do is start drawing vertical lines down. And if I can find a spot where it's going to touch it more than one time, then it's not a function. So this red line is a function. So all linear graphs are functions. However, quadratics are also functions. If you remember that your quadratic equations, they look like a U or an upside down U. And if I were to draw a vertical line, Now this U is actually going to get wider and wider. So, and it's sort of slanting out. So even when I draw my vertical line straight down on these, it's only touching my graph one time. So these are functions as well. When it would fail, it would be something that looks like this, like a letter C, which is a hyperbola. Notice when I draw my vertical line down, it touches it here and here. So this would not be a function. Also, when I have a graph of a circle, so if my graph looked like this, it's kind of lopsided circle, but you get the idea. And if I draw my vertical line down, it's failing because it hits it twice. So these would be examples of not functions when you look at a graph. From an equation, whenever y is raised to an even power, it's not a function. And whenever y is in absolute value bars, or if y is underneath a radical, these are all examples of not being a function. So let's look at the example. So you're doing this in the homework tonight. All you're doing is telling me yes or no. So let's try some of these. So whenever x is raised to an even power like this, this is a function. I could actually rearrange this, move this over, and I get y equals negative x squared plus 1. This is actually a quadratic function, and whenever the x squared is negative, it's just going to be a sad parabola, and this is coming up. Your graph would look like this, and it is a function. So this is yes. Now, if the y was squared, as soon as I see y raised to an even power, this is not a function. Same thing here. I got another y being raised to an even power, so this is also not a function. This next one, x could be raised to an even power. That one works. If I had to move it over, just to show you, this would be the equation that I could graph. So this one is yes. X could have a power on it. This is quadratic. Pretty good so far in being able to determine if something's a function. All right, next we're going to learn how to evaluate a function. So when we want to evaluate a function, again, f of x is the function notation. What they're going to do is, if I give you an equation, let's say it's f of x equals x minus 1. What they're going to do is they're going to give you a number in the parentheses. Remember, this number, or this, what's in here, is the x value. So all you're going to do is take the given function or the given equation, and you're going to replace where we see an x with the number that's in the parentheses, do the math, and f of 4 is equal to 3. Now remember, this is again a fancy way of saying y equals. So the answer that I just got, this 3 is actually the y. And then this number that's in the parentheses is your x. So if they ask you to write it as a coordinate, you would write it as 4, 3. Because your input is x, your output is y. So let's go ahead and try and practice evaluating functions. All I'm going to do is take the number that's in the parentheses and plug it into the appropriate function. So let's try it. Now, notice the letters. You need to pay attention because we've got two different functions here. We've got the f of x function and the g of x function. So whenever the letter in front here is f, I'm going to take my f of x function, which was the x squared plus 3x plus 1. And every place that I see x, I'm going to replace that x with the number that's in parentheses, and I'm going to replace it with a 0. And then I'm going to simplify. So I'm going to plug in, and I get 0 squared plus 3 times 0 plus 1. The 0 squared and the 3 times 0 becomes a 0. So this just becomes 1. So f of 0 is equal to 1. Written as an ordered pair, 0, 1. Going to do the same thing on number 2. I'm still using the f of x function, but this time I'm going to plug in a 1. So 1 squared, 3 times 1 plus 1. 1 squared is 1. 3 times 1 is 3. 1 plus 3 plus 1 gives me 5. So my answer here, f of 1 is equal to 5, written as an ordered pair, 1, 5. Next one, same thing. We're going to replace x into the f of x equation with a negative 1. So negative 1 squared plus 3 times negative 1 plus 1. Negative 1 squared is positive 1. 3 times negative 1 is negative 3. And then plus 1 gives me negative 1. So f of negative 1 is equal to negative 1, again written as an ordered pair, negative 1, negative 1. Now notice we're switching up the letters. Now we're doing the g of x function. So I'm going to be using the negative x squared plus 4x plus 1. Be very careful when your x squared term is negative. So I'm going to plug in the number, and I'm plugging in a 2. Now, this power is only on the positive 2. So I'm going to square the 2, but then that negative sign is going to fall down. So this is actually going to become a negative 4. And then here this will become negative 8. Or sorry, this should have been a positive 2. Sorry. Positive 8 plus 1. And then negative 4 plus 8 is 4 plus 1. And I get 5. So the coordinates here are 2, 5. When they're asking you to replace x with a variable, all we're going to do is rewrite that function. And instead of writing an x there, I'm going to write a t. So for this one, it's just going to be the same thing, but instead of an x squared, I put a negative t squared plus 4t plus 1. So all I did was take out x and put in t. Now the next one, I actually have to FOIL this thing. So we got to be careful on this one. So let me come down here so I have plenty of room. So again, here's my function. Again, remember you're replacing the x with x plus 2. So when I go to plug this in, I'm going to get negative, and then I'm doing x plus 2 squared 4 times x plus 2 plus 1. Now, do not make the mistake of just distributing the 2 to the x and the 2. We got to FOIL this thing, because remember, this is a binomial squared. So I'm going to do x plus 2 times x plus 2, or memorize the pattern. So this will become x squared plus 2x plus 2x plus 4. This will become x squared plus 4x plus 4. You add the middles. So I'm going to replace what was in the parentheses with this. I'm going to distribute the 4 to this x and to this 2. And now this negative sign that was outside here, I've got to distribute. So this now becomes a negative x squared minus 4x minus 4, and then rewrite the rest of this. I'm going to combine my 8 and my 1. All right, now I need to look for my like terms. So I don't have anything to group with the x squared, so negative x squared, but I can add my negative 4x and my positive 4x, that's gone. And then I just have to combine my negative 4 and my positive 9, and that gives me positive 5. So that would be my simplified function plugging in x plus 2. If it asks you to write it as a coordinate, you put in what you plugged in, the x plus 2, comma, negative x squared plus 5. Going to do the same thing, but we're going to replace, and now we're going to do an H. So let's try that. Next, again, same idea, but now we're just having a different variable to represent our function. So I'm going to plug in 2 for x. So 10 minus 3 times 2 squared. Do the exponent first, then multiply. And 10 minus 12 is negative 2. So h of 2 is equal to negative 2. And as a coordinate, it's 2, negative 2. Do the same thing. Plug in negative 2 this time. 10 minus 3 times negative 2 squared. Do the exponent first, then multiply. Minus 12, and I get the same answer. Is yours? Yes. All right, next we're going to plug in an x minus 1. So 10 times 3 times x minus 1 squared. Again, I got to FOIL this thing. Do not just try to distribute the power. So once I FOIL x minus 1 times x minus 1, I get x squared minus 1x minus 1x plus 1. Combine those. So then this becomes x squared minus 2x plus 1. Distribute the 3. Negative 3 times negative 2x gives me positive 6x, and negative 3 times 1 is negative 3. I've got like terms here with the 10 and the negative 3. That's all I need to combine. So I just get negative 3x squared plus 6x, and then 10 minus 3 is 7. Again, written as a coordinate, x minus 1, negative 3x squared plus 6x plus 7. Next, we're going to talk about when they give you two functions. We're going to talk about a piecewise function. Now, this function where they're giving you two different functions in one is called a piecewise function. Now, what we need to look at is this range of values to know which function that we're going to use. So for this one, and actually I'm going to change this to a plus sign here. So change that to a plus sign. Now, whenever the number that's here in the parentheses this is what we need to look at to decide which one we're going to use. So when my number is going to be something that's less than 0, that's in the parentheses, I'm going to use this equation. When my number is going to be something in the parentheses that's greater than or equal to 0, I'm going to use this function. So in the parentheses, I have a negative 1. I can see that negative 1 is less than 0. So the function I'm going to use and plug negative 1 into is the x squared plus 1. So for this one, I'm going to be doing x squared plus 1. I'm using this one. So negative 1 squared plus 1, which gives me 1 plus 1, which gives me 2. So the answer to this one is negative 1, comma 2. For this one, 0, that's in the parentheses, is greater than or equal to 0. So I'm using this equation. So I'm going to plug in a 0. So I'm going to do 0 minus 1. I get negative 1. And then my answer is 0, negative 1. For the last one, I need to look to see which one I want to use. The number in the parentheses is a 1. So 1 satisfies this inequality. It's greater than or equal to 0. So I'm using the x minus 1 again. So I'm going to plug in a 1. 1 minus 1 is 0. So my answer here is 1 comma 0. Now I'm actually going to graph this one. So now I'm going to make my coordinate plane. Let me do the x and the y-axis in black. And then I'm going to graph the blue one, which was the ones that had the numbers less than 0. I'll do that one in blue. Now this is actually a quadratic. It's an x squared. So if I were to graph this, I could take the answers I got that I did in the blue, and I could graph those ordered pairs. So I would only want to plug in numbers that are less than 0. Now I could also plug in 0, and then I'm just going to put an open circle because it can't include that point. So if I wanted to figure out ordered pairs for this equation, I could plug in a 0, and I would get 1. So when I plug in 0, I get 1. But on my graph here at positive 1, I'm going to put an open circle. Then when I plugged in a 1, or a negative 1, which was part A here, my ordered pair was negative 1, 2. So then I can put another point right here. And your graph of your parabola, which we're going to cover, is going to be a U shape. So it would be something like this. For the bottom one, think of it as y equals mx plus b. So for the red one, it's y equals x minus 1. We could put our first point at negative 1, and then we could just rise and run from there. So we could put our first point right here, and then rise 1, run 1, and then this would be our line. Now notice I don't want to make the arrow go down because of my exclusion here. My range can only be numbers for x that are bigger or equal to 0. So this is what a piecewise graph will look like. We'll cover these more later on. Let's practice now finding intercepts. So it says, find where f of x equals 0, which is also known as finding your x-intercepts. So remember, to find intercepts, if we want to find the x-intercept, remember we were setting y equal to 0. And remember in this, our function f of x is just another way of saying y equals. So what we're going to do on all of these is we're going to change the f of x and set that equal to, and make that a 0. So what I'm really solving here is negative 2x plus 10 equal to 0. Because I'm changing all of these f of x's into zeros. And then I'm just solving for x. So let's go ahead and do all of these. So I can solve the first one. I'm just going to add the 2x. You could have moved the 10. It doesn't matter. So then I end up getting 10 equals 2x. Divide by 2. X equals 5. So the ordered pair here, because remember f of x was y, would be 5 comma 0. Over here I got to factor this one. So really what I'm solving here is x squared minus 5x plus 6 equals 0. I'm going to find the factors of 6 that give me negative 5. So negative 2 and negative 3. Solve each one of these. X minus 2 equals 0. X minus 3 equals 0. So x equals positive 2. X equals positive 3. Again, if they want it as coordinates, 2 comma 0, 3 comma 0. For the next one, I'm going to set it equal to 0. Going to factor it. You could also do the square root method, but what you need to remember is you're going to get both positive and negative 4. So the two answers here are going to be x equals negative 4, x equals positive 4. Again, if you write them as ordered pairs, 4 comma 0, negative 4 comma 0. I know I sort of went into number 4, So let me come down here. Always, 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 whenever you are going to try to factor something, look for a GCF first. So I can factor out a GCF of x. Now what remains is the difference of two squares. So GCF, x minus 9, x plus 9. Set each one equal to 0, including the GCF. Don't forget about that guy. So my first answer is 0. My second answer, positive 9, negative 9. And again, the order that you write these doesn't matter. So again, as x-intercepts, 0, 0, 0, 9, 0, and negative 9, 0. Last one on this slide. Again, replace f of x with a 0. I'm going to get rid of the denominator, multiply both sides by 3. So 5 minus 6x, 0 times anything is 0. So whenever you have something like this and you're finding an x-intercept, you're really just setting the numerator equal to 0. Divide by 6. And x equals 5 over 6. Again, as an ordered pair, 5, 6, 0. Remember, your x-intercept will always be a number, 0. Because it's touching your x-axis at that point. Two more examples, and then we're going to move on to domain. They want us to find where f of x equals g of x. So all I need to do is take what f of x equals and what g of x equals and set them equal to each other. So I'm going to solve x squared plus 1 equals 3x minus x squared. I need to get all my like terms to one side and set this equal to 0. So I'm going to go ahead and add the x squared. I get 2x squared plus 1 equals 3x. Move the 3x. 2x squared minus 3x plus 1 equals 0. I now need to factor this thing. The numbers are small enough where I can guess and test. Factors of 2 are going to be 2 and 1. And then factors of 1 are just 1 and 1. And notice, to get a positive 1, they both have to be negative, because that's the sign of the middle. You can quick FOIL this, make sure everything looks good. This gives you negative 1x. This gives you negative 2x. When you add them, you get the middle. So it did work. If it didn't factor, then you'd be resorting to quadratic formula or completing the square. Set each of your factors equal to 0. Add 1. Divide by 2. Add 1. So my two answers where the two functions are equal are going to be when x equals 1/2 and x equals 1. It didn't ask for intercepts. It just wanted what x equals. I'm going to do the same thing on number 2. So I'm going to set x squared minus 1 equal to negative x squared plus x plus 2. So now I'm going to get my like terms together. 2x squared minus 1 equals x plus 2. I now need to move the x over and the 2 over. I could try to do it at the same time. So now I get 2x squared minus x minus 3 equals 0. Again, I got to factor this thing. So again, small enough where I'm going to guess and test. So factors of 2x squared are going to be 2x times x. And my factors of negative 3 are going to be negative 3 and positive 1. Again, you should FOIL this real quick. I get 2x when I do outside. I get negative 3x when I do inside. When I combine them, I do get the negative x that I wanted in the middle. So I did place everything in the right spots. You could also do the whole factor by grouping if need be. But again, when your numbers are small like this, you could probably guess and test pretty quickly. All right, so now set each of your factors equal to 0. Add the 3. 2x equals 3. Divide by 2. And x equals 3 over 2. Over here, subtract the 1. And the two values of x when the two functions are equal will be positive 3 over 2 and negative 1. So that is it for part 1 of section 2.2.